All right, for this lesson, I'm just going to introduce experimental probability, and then we'll work more with it on Wednesday, okay? Um, so let's get started. It says previously you learned to describe the probability of a chance event using theoretical probability, guys. How many ways can you get it out of the total? But in this lesson, we're going to be looking at experimental. So previously we have been doing theoretical. We've been calculating theoretical probability, which is just the number of ways for something to happen. Out of the total. That's what your homework was on last night. What you should have done last night. All right, but this time we're doing experimental. Experimental is when you actually conduct an experiment. And it's not the number of ways for something to happen. It's the number of the frequency of which something happened. Like how often did something happen in the actual experiment you conducted out of the total. So let me just put right here for experimental probability. You're going to be looking at the frequency of an outcome over the number of trials, the total number of trials. And trials is just how many times did you conduct an experiment? How many times did you flip the coin? Was it 10? Was it 20? Was it 100? All right, so let's take a look at this example. A bag with 20 cards has 14 star cards. Another bag with 50 cards has 14 star cards. Chantel selects a card at random from each bag. From which bag is Chantel more likely to select a star card? So I am going to, and you all probably already have an idea, but I'm going to kind of just chart this out. So in bag A, I got bag A and I have bag B. I'm just going to do a little chart. And then we have star cards. So if you have star cards, then you also have non-star cards. Cards that are not stars. So I'm just charting this out so we can see easily which bag she's more likely to select from. And we'll talk about which bag has more of what. So each bag has 14 star cards. So bag A has 14 star cards, but they only have 20 cards in all. If 14 of those are stars, how many are not stars? So that would be 20 minus 14. That's 6 non-star cards, okay? So in other words, they have more star cards. Now, bag B, on the other hand, has 14 star cards. So how many non-star cards do they have? Because they have 50 cards in their bag. So what is 50 minus 14? That's 36. So 36 of their cards are not stars. So they have 36 cards that are not stars and 14 that are. They have more non-star cards, or bag B does. So which bag is she more likely to select a star from? Well, the bag that has more stars. versus non-star cards. So Chantel, I'm going to put Chantel is more likely to select a star from the bag with 20 stars, from the bag with 20 cards, which is just bag A. Y, let's put the Y. I'm going to use BC for because it has more star cards. And you can't say it has more star cards than bag B. Bag B also has 14. But bag A has more star cards than it does non-star cards. All right, we're going to skip one because we've already answered that. We answered that right here. All right, and we're going to go on to look ahead. That's what we want to get into. All right, each time Chantel selects a card from a bag, she performs one trial. So every time you actually go in and do something or flip a coin or pick a coin from a bag, that's a trial. That's the trial part of your experiment. Chantel uses a box of marbles to conduct a different experiment this time. She selects a marble, records its color, and then puts it back in the box. She does this several times. In all, this is what happened. So in all, what did she end up with? She ended up with 5 red marbles, 3 blue marbles, and 2 yellow marbles. Notice it did not say if the bag contains or if the box contains 5 red, 3 blue, and 2 yellow. What's the probability you'll select this? That is theoretical. She selected already. So she selected this. So that has to be in an experiment because she actually did it. All right. 5, 3, and 2. Okay. Those are your frequency. That's the frequency of the outcome. Frequency is how often did something happen. So for the color red, how often did that happen? Well, it happened. She picked it 5 times. For the color blue, how often did she pick the color blue? She picked it 3 times. And then for the color yellow, she picked it twice. These are all frequencies. Sometimes your frequencies will be represented with tally marks or dot plots, or just in a table like I did. All right, let's go on. It says Chantel can use experimental probability to describe the likelihood of getting a particular result in the experiment. So how do you calculate experimental probability? All right, it's the number of ways you got something out of the number of trials. So it says number of favorable outcomes. So I'm going to put it's the number of ways you chose something. Well, I'm gonna put you actually got something. Because if it's the number of ways you actually got something, that should help you to see that you actually performed a trial or an experiment because you actually got it. And then I'm going to put total here. So it's the number of ways you actually got something out of the total number of trials. So how many trials were in Chantel's experiment? Well, what was her total frequency? So she selected 5 red, 3 blue, and 2 yellow. That's going to be a total of 10. That's 10 trials. All right, based on her results, because this is an experiment, so she actually got something. What is the probability of selecting a blue? Based on her result, it will be 3 out of 10, but this is experimental probability because she actually did it, okay? As a decimal, if you T-bow that or punch it in the calculator, it becomes 0.3. And as a percent, it's 30%. So I just expressed it as a fraction, my answer as a fraction, and as a decimal, and as a percent. All right, and it goes on to say that on C, a probability can be expressed as a fraction, decimal, percent. We talked about that yesterday. What is the experimental probability of selecting a red expressed as a fraction, a decimal, and a percent? Okay, let's do red this time. Well, she selected a red 5 times. So that would be 5 out of 10. 5 out of 10, you probably won't see on the ACAP test, but you will see 1/2. Because if you skip count by 5s, it takes you 1 time to get to a 5 and twice to get to a 10. Now, 1/2 is the same as 0.5 as a decimal, or 50% half, guys. All right, you can think of all the marbles in the box as the population. So all the marbles in the box is the total population. And the results in the experiment as the sample. So your results are the sample. All the items, and I don't want to really say all the items in the box. All the items you have per scenario, all the items in the scenario. It may not be a box. All the items in your scenario are called your population. All right, it says Chantel repeats the experiment and this time gets 4 red marbles. But so she's still doing it out of 10, but so we're gonna pretend like the frequency is still, or the trials is still 10 trials. Because if she repeats it, she's using the same amount of trials. So she's still gonna use 10 trials. Just said she's just gonna do it again, but this time it's another set of 10 trials. But I don't know how many blue or how many yellow she has. So the blue was a question mark. The yellow is a question mark. But I know this time she got 4 red. But it says she repeats it. So I do know it has to be 10 trials because she repeated it. So it has to be the same amount of trials when you repeat something. All right, so if I want the probability, she'll select the red. In this case, in the second experiment, it's going to be 4 out of 10, or 2/5 simplified. If you punch that in the calculator, you're going to get 0.4 or 40% as a percent. So let's take a look. It says, why would it be reasonable to predict that between 40 and 50% of the marbles in the box are red? Okay, what do we get for red up here? So the first experiment, the amount of red was what percent? Where is red? Okay, here's red. What is the experimental probability of red? So her red was 5 out of 10, or 50%. So in the first experiment, it was 50%. And in the second experiment, selecting a red, getting a red was 40%. So I'm going to put, because in the first experiment it was 50, and in the second experiment it was 40. So I would expect that about between 40 to 50% of the marbles in the box are red. The first experiment contained 50% red marbles. The second experiment contained 40% red marbles. We should expect the box to contain between those two. A number of red marbles between these 2% then. Let's see if I'm gonna tackle this one. I tell you what, you go ahead and read number 3. I gotta run to the kitchen. I got bacon on. Read number 3. Let me turn this bacon on. All right, sorry about that. All right, what does it mean if the experimental probability of an event is 1, which means certain? That means that it means we got the same outcome all the time. Like if you kept getting a red marble over and over and over and over and over and over, that would have a probability of 1. Because it seems like the only color in there is red if all you pull is red. Or if you keep getting yellow over and over and over and that's all you get, then that experimental probability would be 1. And so you would think the only color in there would be a yellow. And it might be one of some other color in there, but during an experiment, if that's all we pull is one of a certain thing, then we think that's all we have, which is a probability of 1. All right, let's go to this page. That's page 692. All right, we'll go to page 692. This time your frequency, how often something happened, is written as tally marks. So it says Aaron rolls a number cube and records the results. So Aaron rolled the number 1 once, the number 2 once, the number 3 4 times, the number 4 none, the number 5 twice, and the number 6 also twice. It says based on these results, what is the probability of rolling each number? All right. So let's take a look at it. And I want to see what I put on this next page. Okay, a different page. That's good. All right, I'm going to show you this dot plot. All right, so you can look at the dot plot to see you got the numbers 1, 2, 3, 4, 5, and 6. The dots represent the frequency, how many times. I don't want you to see a dot plot and not know what it means. So the number 1 happened once, the number 2 once, the number 3 4 times, the number 4 not at all, the number 5 twice, the number 6 twice. That's how you read a dot plot. But it doesn't matter whether it's tally marks or a dot plot or just in a table. You do it the same way. If you want the probability of each one, and I'm going to use this dot plot because I can see the dot plot and this right here. All right, the probability of rolling a 1. So how many ones were rolled? What were the number ones rolled? Well, it was only one roll out of how many? So what you want to do is figure out, well, how many trials did you have? Okay, so let's take a look at it. Well, how many trials did we have? Because we don't know. Not right now. We got to go back up here and add. So how many times did we roll on the 1? That means they rolled on the 1 once. There was 1 trial for that one. How many times did they roll on the 2? Another. The 3, 4. The 4, none. And this is all frequency, guys. If you tally up your frequency, it's going to give you the total number of trials. Okay, so the 1 was 1. The 2 was 1. The 3 was 4. The 4 was 0. The 5, they landed on it twice. And the 6, they landed on it twice. Which means they had to, we're going to add up these. They had to roll that die 2, 4, 8, 10 times. So this is your total number of trials. So they only landed on 1 out of the 10. How many times did they land on 2? Well, another 1 out of 10. How many times did they land on 3? Well, that would be 4 out of 10, or 2/5 if you simplify. How many times did they land on 4? The probability is just a flat out 0. They didn't land on it. All right, 5. Well, they landed on the 5 twice. So that's 2 out of 10, or 1 over 5 in simplest form. How many times did they land on the 6? Also 2 out of 10. Okay, and I'll tell you all, we could have also counted the dots for the frequency, okay, for the total number of trials. You could have count all the dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would also give you the total number of trials, okay? All right, let's take a look at page. What page is this? 694, guys. All right, let's look at page 694. And we're going to start off with a dot plot. Okay, I'm going to tell you, I'm going to count the trials already. It says on the dots, in a class, 18 students each toss a coin 10 times. Excuse me. They record how many times the result is head. It's heads. Based on these results, what is the probability of getting more than 5 heads? So down here, this tells you one of those students landed on heads once. One landed on heads twice. 3 landed on heads 3 times. 1 landed on heads 4 times. 1, 2, 3, 4, 5, 6. 6 landed on heads 5 times. 3 of them landed on heads 6 times. 2 of them landed on heads once. And 1 of them landed on, 2 of them landed on heads 7 times. And 1 of them landed on heads 8 times. All right. So it says, what is the probability of getting more than 5 heads? So I'm going to look at all 18 of the students. You're not just going to count the dots for the trials, okay? I know they flipped them 10 times each, but we're looking at out of the 18 students, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18 guys. So there are 18 trials. Now, if I were just doing this for one student, there would be 10 trials. But I'm not looking at just this for one student. I'm looking at it for all 18. So I'm looking at how many times, the greatest amount of times each student landed on heads. So I need to be looking at each student, which is all 18 of them, because this represents the number of times each student land on heads. Okay? Not the number of times one student landed on heads, but each student. All right, so and that if it was one student, it'd be out of 10, because one student only flipped it 10 times. But I'm looking at all 18 children. So my total number of trials is 18. All right, so how many? It's got to be getting more than 5 heads. So that would be 6, 7, and 8. Well, how many landed on 6? 3, 2, and 1. Add those together. That's going to give me 6 out of 18, which you will not see that. Maybe you won't see that. It may be in simplified form. If you skip count by a 6, you'll get to a 12 and then 18. So that's 1/3, guys. All right, let's take a look at this one. A grocery store prints coupons on randomly selected receipts. A coupon was printed on 18 of the last 1,200 receipts. Based on the results, what's the probability that a coupon will be printed on the next receipt? So all you have is a total of 1,200 receipts. Those are the total number of trials, because those were the total number of receipts. And then coupons were only printed on 18 of them. So this is what actually happened. Basically, all I need to do is take 18 and divide it by 1,200. That's it. And I'm going to tell you guys, I'm going to divide this one by 2. Now, nobody is going to skip count by 2 to get to the 1,200. At least I hope you don't, because you're going to run out of time on the test. All right, so 18 divided by 2, just use the calculator, is 9. If you take 1,200 divided by 2, you get 600. All right, both of these you can divide by 3. 9 divided by 3 is 3. 3 divided by 6 is 2, but add the 2 zeros. So that's 3 out of 200. And you can't simplify that any further. Okay, so 3 out of 200 is your fraction. Now you can change that to a decimal. As a decimal, if you do 3 top in, bottom out, or you punch in the calculator 3 divided by 200, you're going to get 0.015. And then if you change it to a percent, that's going to be about 1.5%. So I just expressed my answer as a percent, as a decimal, and as a fraction, guys. Soledad, I'm on 9. Soledad has a spinner with a red, a blue, and a white section. And you can see the number of times she landed on red was 5. The number of times she landed on blue is 9. And the number of times she landed on white is 6. Okay? This is how often she landed on it. The frequency just tells you how many times she did it. All right, so it says she spins the spinner 20 times. So I can tell you right now, when I add 5 and 9 and 6, it's going to give me a total of 20 trials in all. Based on her results, what's the probability of the spinner landing on each color? So I'm going to do this. This P stands for probability. Probability that it'll land on, let's do red, is 5 out of 20, or 1 out of 4. And it's 0.25 as a decimal, or 25% as a fraction. All right, the probability is she'll land on blue. And keep in mind, you can use a calculator. So just punch in 5 divided by 20 or 1 divided by 4 to get this. And to get this, slide your decimal 2 places to the right. All right, blue would be 9 out of 20. That's already simplified. But as a decimal, that's 0.45 or 45% as a percent. And for white, the probability of landing on a white is 6 out of 20. But you can divide both of those by 2. That's 3 out of 10. So that's 0.3 or as a percent, 30%, guys. All right, that's it for the introduction of experimental probability. We'll do more with it tomorrow. Thank you.